In this chapter, we will learn how to set up the nameplate for the enemy characters. The nameplate is displayed on the HUD attached to the enemy characters as they move. It can display the enemy name and the health for the character. We will implement this in this chapter. Currently, we have the boss enemy character in the level. Let us change this back to sword and shield enemy to demonstrate the nameplates. Open BRPG experience. Under components, change B magic boss enemy bot spawner to B sword shield enemy bot spawner. Open it. Let's keep the number of bots to create as 2. Add 2 bot names. Enemy 1, enemy 2. In the folder Content UI Indicators, you can find nameplate related blueprint components and assets. We will reuse the Indicator Manager component, Nameplate Manager component, the nameplate source and WO nameplate, the widget which will be displayed along with the moving enemy character. The core Lyra Indicator Manager is a C++ component. Let us learn how to configure them first. Open RPG Core Game Feature Data. Add a new component. Actor class as Lyra Player Controller. Component class as Lyra Indicator Manager component. Next, we need to also add an indicator layer in the Lyra HUD layout. Open WRPG Core HUD in the folder RPG Core User Interface. Search for indicator layer. Add it to the canvas panel. Adjust it to cover the entire canvas. And anchor it fully stretched. The nameplates will display in this area. This is the base configuration. The Lyra Indicator Manager is a more generic feature to display widgets on top of the HUD canvas. We will use this feature to display the nameplates. Let me first explain at a high level how nameplates works in Lyra. In the folder UI Indicators, you can find 2 blueprint components, Nameplate Manager component and the Nameplate Source component. Nameplate Manager is a controller component. We will be adding this to the player controller. Nameplate Source component is also a controller component. We will be adding this to the enemy character itself. These 2 components uses the gameplay message subsystem. This is a message broadcast and receive system which is included as a plugin within Lyra. The main purpose of the gameplay message subsystem is to send messages between 2 components or even between the components and the user interface event graph. The communication happens using channels. A channel is represented by a gameplay tag. The receiver of the message will be listening to the messages in the channel, and the sender will be sending the messages in this channel from a different component. The message can be sent any number of times and it will be received by the listener. We haven't used this till now. Indicator components are a good source of research and learning this subsystem. Welcome to the course Unreal Engine 5.6 Build an Action RPG using Lyra Framework. In this course, you will learn the core features of Lyra Framework from scratch in a week with all free assets from Fab Marketplace. In this to-the-point step-by-step practical course, you will learn the skills to develop melee, archer and magic abilities. We will start the course by creating a new game feature plugin RPG core with an RPG experience. You will learn the foundation of Lyra locomotion by building a simple, lightweight Lyra-based locomotion system from scratch. We will use the free Mixamo animations, add root bone, and build different weapon animation layers. We will create a simplified extendable gameplay attribute system with health and stamina attributes to learn the core gameplay ability system. The Equipment Manager and the Inventory Manager are covered to equip swap weapons. Inventory Fragment system is covered from scratch, which is the foundation to build any type of inventory system. Approach to create new weapon textures is covered for the quick bar. Interesting ideas to craft your combat system using animation notify system and gameplay events. You will build melee attacks which can be interrupted with weapon tracing techniques. Advanced bow and arrow system is covered in this course. We will also build an AoE attack system for the boss enemy. Free Niagara effects are used and techniques to convert cascade effects to Niagara is covered. We will build a step-by-step artificial intelligence system for the enemies using state trees. You will learn how to build the main menu with a level background, learn use cases for UI materials and animations. You will also learn to create your own multi-layered RGBA mask textures for the logo. Apart from Lyra starter game, you will learn innovative approaches to reuse and customize marketplace assets to build unique assets for your games. Learn Skeletal Editor to modify skeletal meshes. I have also provided my level creation tool for artistic needs. It is provided free to use in this course. It is a complete blueprint-based tool with lots of automation features to build huge environments in no time. This course will be periodically updated with more features related to RPG. The core idea behind this course is to build the research skills to explore a detailed framework like Lyra. By the end of this course, you will get a good knowledge in the Lyra framework to start building your own game. The nameplate source broadcasts a message, gameplay message nameplate add when the enemy character is spawned. It also sends a message, gameplay message nameplate remove when the enemy character is dead. This message will be received by the nameplate manager component, which listens to this message. In a reverse way, the nameplate manager component broadcasts a gameplay message nameplate discover message, which is listened by the nameplate source, which is used to register the nameplate source. We will reuse this system. We don't need to make major changes to this. We will do just some configuration. An important thing to know is that we have the system in the content folder, but the gameplay tags used by the system is registered in the INI files related to the shooter core. Remember, we don't have the shooter core. So if you click on the gameplay tags, they disappear. Just undo the changes. We will add these gameplay tags so that they don't disappear. Gameplay message nameplate add, gameplay message nameplate remove, gameplay message nameplate discover. We will add these tags in the manage gameplay tags section in the project settings, gameplay tags. Now we are good to go. Next, open the experience definition, be RPG experience. LAS RPG shared components is the Lyra action set configured for components. We will add the nameplate related components here. Open it. Add a component. Select actor class as Lyra player controller. Component class as nameplate manager component. Add another component. Select actor class as be enemy sword shield. Component class as nameplate source. The main logic to display the nameplate widget is in the nameplate manager component. In the function register nameplate source, the widget W nameplate is loaded to the indicator class. And then the indicator is added to the enemy character. You can try different things in this area to customize for your needs. Finally, in the widget W nameplate, the actual logic to display the name and the enemy character health from the health manager is available. I will change the height of the health image a little bit. Change the Y value to 5. Update visibility function decides when to show the nameplate. I will make a small change here so that if the teams are different, we will set the visibility as visible. In our case, the player character and the enemy character are in different teams. Let us try to run this now. We can see the nameplate. Now let us make a simple change to the nameplate widget. so that we get the health bar displayed to red below a certain value. As we have kept our damage to 50 points, I will check if the health value is less than 70, then display in red. For this, we will use a property in the material instance used in the nameplate widget, active RGBA. We will access this in blueprints in the event graph. In the custom event, set health bar %, the health % value is available. It is received from the get health normalized function in the Lyra health component. This normalized value will be from 0 to 1. So for 70 points, it will be 0.7. Check if the value is less than 0.7. If so, then set vector parameter value. Parameter value as active RGBA. Value as red. Test the level. You can see after a hit, the health reduces to 50, which is less than 70, so the bar turns red.